If particles are supposed to be curled up energy filaments, where did those filaments come from when we started from empty space? In the energy filament theory, the answer does not live inside any single particle. It lives in the vacuum itself, which is not empty at all but a restless energy sea that first grows preferred directions, then grows textures along those directions, and only then condenses some of those textures into real, thread-like structures. You can think of the universe not as a mute black box but as a huge invisible ocean that never quite calms down. Every patch is shaking, quivering and throwing off tiny ripples. At the beginning this motion is completely messy, like stirring a very thick soup in a pot at random. Your hand looks chaotic, but if you keep stirring for long enough the soup will quietly pick a smoother route, a narrow lane where the flow meets the least resistance, and more liquids will slip along that lane. Out of pure chaos, a best path appears. The energy sea behaves in just this way. When it is shaken for long enough in all directions, some directions become a little easier for disturbances to follow than others. Tiny wave packets and oscillations choose these easier directions slightly more often, and because they use them more, those paths get smoother and straighter. Over time, a surface of the sea stops being completely symmetric. It carries faint directional textures, like invisible grooves where motion flows more comfortably. Even though no external hand drew them, those grooves are the first step. Once a groove exists, only a small extra push is needed to turn it into a filament. A patch of the sea along that groove gets rolled up, pulled tight and closed on itself. So the good path is no longer just a direction in a flat surface but a raised, solidified thread that can hold a stable flow. In short, a texture is a favored lane, and a filament is that lane pulled out and locked into a strand. This may sound abstract, but real physics already shows us how continuous fields love to grow threads. In one class of superconductors, the magnetic field does not stay smeared out. It bunches into thin spikes called flux tubes, where almost all the field lines squeeze into narrow cores. In superfluid helium, the flow does not just swirl vaguely. It forms quantized vortex lines, each a tiny, stable whirlpool with a well-defined circulation. Cold atomic gases in the lab can arrange those vortices into clean lattices, like a crystal made of tiny whirlpools. Plasmas do something similar with electric currents, forming narrow current filaments where charge prefers to run. Very strong laser pulses shot through air burning narrow channels of altered refractive index that guide the light as light filaments. In all these examples, a system that looked smooth and continuous at first spontaneously organizes into long, string-like structures once the right conditions and stresses are present. One more mental picture makes the idea of the vacuum growing threads feel natural. Imagine a calm pond and your fingertips tracing the same line on the surface again and again. At first you only see random ripples spreading everywhere. After many passes, a subtle groove appears where the water remembers your path, and new ripples prefer to follow that groove rather than cross it. The energy sea, constantly shaken by microscopic fluctuations and tension shifts, leaves behind similar sea scars, places where direction and flow line up so well that they are reinforced instead of erased. Those scars, once lifted, tightened and closed, become real energy filaments. From this perspective, what we casually call vacuum is never truly idle. On very small scales, it is always exploring directions, smoothing some into textures, and occasionally locking those textures into loops and strands. Later in the story of this theory, those strands would be curled into rings to become particles. Their inward or outward twists will show up as different kinds of charges, and the slopes and clashes between their surrounding textures will be what we feel as forces. But the origin of all those later details is already hidden here. A vacuum that can grow threads out of its own motion and tension instead of needing pre-existing bits of stuff. So the next time you hear empty space, you can replace that phrase with a more accurate picture, an energy sea that patiently writes lanes into itself, turns some of those lanes into filaments, and uses those filaments as the raw material for everything else. Tap follow, share it on New Physics, Clear Universe.